Welcome to the first video for the Module 2, Solving Systems of Linear Equations. Here we have a system of linear equations. Notice they're both equations of lines, so independently they are equations that we would have seen in Module 1. And our goal in solving this system of linear equations is to determine if there are unknowns, so x and y, that satisfy or make both of our equations true. Okay, so I'll take a look at visually what this looks like. There are three possible cases for the solutions of linear equations. First is where we have two lines that intersect in exactly one place. So this is one solution or one point of intersection. Then there's a case where we can have no solution for our set of linear equations, and that's when we have two lines that are parallel but not equal, and so they always stay equal distance apart and will never intersect. So these are parallel and not equal. And the second case, or the third case, is where we have a line, and these are all general cases. You could draw these lines in any way, but we have another line that is parallel to the first line but equal, and therefore we have points of intersection, an infinite number of points of intersection all along this line because they overlap everywhere. So this is where we have parallel and equal lines. So we want to determine these solutions. The first method that we're going to look for to solve system of linear equations is by graphing. So if we're given a system of two linear equations, we want to graph both the lines. So we're going to graph them, and if a solution exists, it is going to be represented by our point of intersection of the two lines. Okay. Recall all of our graphing methods from Module 1. You might want to look back at some of your notes from the last unit. And we can consider graphing using the slope y-intercept form, y equals mx plus b, or by determining the x and y-intercepts for each equation. To solve the following system of equations graphically, we can graph each of the equations separately. We end up getting equation 1 at x minus 2y is equal to 2, and equation 2 at x plus y is equal to 5. Each of these equations can be graphed as lines independently by either using the x and y intercepts of each equation or by graphing using the slope y-intercept form where y is equal to mx plus b. I've included all the work here to solve for the x and y intercepts of each equation, and if you need a review of the method of this, please refer to the videos in Module 1. Now that we have both the equations graphed, we can determine the solution by looking at the point of intersection of the lines. When we take a look at it, we can see that they intersect at the point 4, 1. We can either express the solution as an ordered pair, 4, 1, or using the values of x equals 4 and y is equal to positive 1. We're going to practice by solving the following systems of equations using graphing method. Looking at example A and equation number 1, we can solve for the x and y intercepts. Once we have the x and y intercepts of equation 1, we can sketch equation 1. Our x-intercept of equation 1 is negative 4, and the y-intercept of equation 1 is negative 2. Now, looking at equation 2, we can also determine the x and y-intercepts. We find equation 2 has an x-intercept of 4 and a y-intercept of 2. Now we can graph equation 2. Looking at the graph of this system of equations, we can see that these lines are in fact parallel, but not equal, and will never cross one another. Therefore, there is no solution. And just as a reminder, to determine that they're parallel, you can calculate the slope of each of the lines by looking at the rise over run of each of the equations, or by putting the equations into y equals mx plus b form. Looking at the second problem, we have two new equations that we're looking for a solution to. We want to graph each of them using the x and y intercepts and determine what the solution is if there is one. Now that we've determined the x and y intercepts of each line, we will plot them. Once you plot the x and y intercepts, we can join them to form a straight line that expresses the equation graphically and determine the point of intersection. And we can see that our points intersect at the coordinates 2, 3. So our solution is x is equal to 2 and y is equal to 3. In part C, we have two new equations, which we will graph using the points of intersection again. Now that we've determined both sets of x and y intercepts, we can put them onto our graph. Notice on the x-axis, I've gone up by 2 units for every square, and on the y-axis, I've gone up 1 unit for every square. This is in order to show the x-intercept of x is equal to 9. Once we graph both lines, we can see that the point of intersection and solution of the system of equations is given by the point -6, 5. Okay. It's fair to say that your accuracy in this method is tied very closely to how accurately you are able to graph your lines. So when I'm performing my solutions here using a tablet, I am unable to use a ruler, but when you're doing your work on your own, please make sure that you space your points evenly, as well as graph them as accurately as possible, and use a straight edge to connect your x and y intercepts. In the fourth example of solving a system of equations graphically, we're going to follow the same method as in the previous 3 examples. So pause the video and compare your solutions to what is here. When you plot the x and y intercepts of these lines, you can see that the y-intercepts are very close to one another, and so are the x-intercepts. But when we take a look at them, these green points are to the left and below of the red points, and therefore you can see that they won't intersect in between these sets of values. They're going to intersect further to the left. So I'm going to go ahead and join those lines up. Okay, these lines are actually very difficult to draw, and it's difficult to determine the actual solution graphically. I, in fact, knew where it was and was able to shoot for it when I drew my lines, but it's useful to have a more accurate method to determine the points of intersection. And we're going to look at using solving algebraically by elimination and substitution to solve for the point of intersection rather than just looking at it graphically. Just before finishing this video, I wanted to look at Desmos.com and solving graphically using computer software. So we go to Start Graphing, and we can type in each of the functions. As we type in each of the functions, the relevant graph will appear. And our second function, our second line is 8x plus 5y is equal to 18. And we can see that, like I said in the earlier part of the video, the point of intersection does not occur between our intercepts, and we can look later on, our point of intersection seems to appear somewhere in this region, and we can identify that region by clicking on the point and determining that the point of intersection is -410. So good job, way to stick with this. Make sure that you give it lots of practice, take a look at the questions posted online, and in the next video we'll be looking at how to verify a particular point is a solution to a system of equations.